You know, every single time you visit a website, send an email, or stream a show, you're relying on this one brilliant little rule that keeps the entire internet from just falling apart. Today, we're going to pull back the curtain on that unsung hero, the default route.
So let's start with a puzzle. Imagine a router. It's basically the internet's traffic cop. It gets a little piece of data, a packet, and it looks at the destination address. And it has absolutely no idea where that is. So what's it supposed to do? Just drop it? Panic and send it everywhere? Well, the answer to that question is actually the key to how we all get online.
To really get to the bottom of this, we first have to understand what a router's fundamental job is. It's all about making one big decision over and over again. It follows this super logical four-step process. First, it looks at the destination IP address on a packet. Then, it checks that address against its own internal map, which is called a routing table. If it finds a match, great. It picks the best path it knows and sends the packet along on its journey. Simple enough, right?
But here's the kicker. The internet is gigantic. We're talking millions of networks that are changing constantly. A router, especially the little box sitting in your home, can't possibly know about every single destination out there. So what on earth does it do with traffic that's headed for a place it's never even heard of?
Well, the solution is this incredibly elegant and powerful rule called the default route.
Think of it as the router's ultimate plan B. It's this special little entry in its rulebook that's basically a catch-all. It's the fallback plan for any destination it doesn't have specific directions for.
In network speak, it looks like this, 4 zeros with a /0. Now, that /0 part, it's called a 0-bit mask, but all it really tells the router is, hey, don't sweat the details of the address. This rule matches everything. It's the ultimate wildcard.
So this entry gives the router one simple, crystal clear command. It's the digital version of saying, look, if you don't have specific directions for this, just send it this way, and someone else will figure it out.
And that's exactly why you'll often hear network engineers call it the route of last resort. I mean, it makes perfect sense, right? It is literally the last option the router is going to consider.
Now, what's really cool is how this one simple rule is what connects your home or your office to the entire global internet. It's the magic ingredient that makes the whole thing work for us.
I mean, think about it. The router in your house, it's got a tiny amount of memory. There's no way it could store a map of the entire internet. It would explode. So it doesn't even try. Instead, its job is much simpler. It knows about the devices right there in your house. And for everything else, yep, you guessed it. It uses the default route to just pass that traffic off to your internet service provider. The ISP has the big, powerful routers that can take it from there. The default route is basically the escape hatch.
Okay, quick but really important clarification here, because this is a classic point of confusion. You've probably poked around your computer's network settings and seen the term default gateway. Well, that's just the IP address of your router. It tells your PC where to send any traffic that isn't for your local network. Now, the router itself then uses its default route to send that same traffic out to the big wide internet. So same purpose, just different devices.
But this brings up a really good question. If that 0000/0 route matches every possible address, why doesn't it just hijack all the traffic? I mean, why doesn't data meant for your printer accidentally get sent out to the internet?
It's because routers live by one simple golden rule. The most specific route always wins. Look at this first example. The destination is on the local network. The router sees two options, a very specific route for that local network and the generic match everything default route. Well, the local route is a much better fit, so it wins, hands down. But in the second example, for an external address like Google's, there's no specific local route that matches, so the only option left is our trusty default route. It only gets used when there's no better choice available.
So what happens when this crucial safety net is missing? What if a router doesn't have a default route configured for some reason? Well, you get a digital dead end.
The result is pretty simple. Failure. If a router gets a packet for a network it doesn't know and it has no default route to fall back on, it has no choice but to just discard it. Poof, gone. The data hits a brick wall, your connection fails, and honestly, this is one of the most common problems network technicians look for when troubleshooting.
So, let's wrap this up. The default route, our good friend 0.0.0.0/0, is the router's essential game plan for handling the unknown. It's the route of last resort, and it always loses out to a more specific path. And most importantly, without it, your connection to the internet simply won't work.
So, understanding the default route is the foundation. It's the simple rule that makes all the complexity possible. But it also raises the next big question, right? How do those massive routers at the ISP build their huge detailed maps of the internet in the first place? Well, that is a story for another explainer.